Coming up on This Week in Radio Tech, Dana Puopolo joins us to tell Chris Tobin and me, remind us about how important it is for that big hunk of brass, copper, and stainless steel at the top of the tower to be properly tuned. I mean fine-tuned. It's important. We'll find out why coming up. This Week in Radio Tech is brought to you by Lavoo and the Crystal Clear Virtual Radio Console. Crystal Clear is the console with a multi-touch touchscreen interface. And by Direct Current, broadcast e-newsletter. Get Direct Current in your inbox every Thursday with technical pointers putting you and your facility at an advantage. Welcome into This Week in Radio Tech. This is the show where we talk about everything from the microphone to the light bulb at the top of the tower. And, oh boy, are we going to be kvetching on this episode. I'm not even sure I know what that word means. I'm sure somebody who speaks Yiddish can explain that pretty well. I wonder if Dana could. We're bringing Dana Puopolo in just a minute. He's our guest. First of all, just in the nick of time for the show, Chris Tobin is with us. And by the way, I'm Kirk Harnack, your host, and I work for the folks at the Telos Alliance. So if I speak biased toward them, it's probably because they write my paychecks every couple of weeks. So I really appreciate their support. I really do. Chris Tobin, welcome in. Where are you today, sir?
I'm just at my brother's place at a family house. So
all right.
Mass transit was a little behind schedule, but I think I got it working, and everything was in place except for the classic Windows 10. I'm ready to pound it, throw it out the window, and toss it in front of a bus opportunity. Because I left my Mac at home, so I'm like, the one device that seems to reliably work, I left behind. I'm mistaken. I was to use Microsoft.
I know. I've tried doing Skype on other platforms as well, and the Mac is the one that it seems to be least troublesome on for me. You find that for you too?
Well, yes. I actually have a friend of mine who works at a television station and oversees the IT technology stuff. It's funny. He was telling me that most graphics folks in TV are Mac users, so it's a given. Sure. And he's built their entire Skype infrastructure on the Mac, and he realized recently, he's like, I totally forgot, but we have maybe 1 in 200 shots of a problem with the Skype on the Mac platform. But he remembers, he goes, but when we've done other stuff with other folks and we're using Microsoft products, it's always a hassle, even after you've got it all set up. And I can tell you from my personal experience, I have this all set up every week, the same setup, the same thing, same machine, same ports, you name it. And for some reason, Windows 10 says, hey, I found new hardware. No, you didn't. And then Skype says, we found new hardware. Would you like to use this instead of the the onboard audio? I'm like, no, you didn't. I didn't turn anything off or change anything. And never had this problem with Windows 7 Pro. I'm serious. Never. I mean, Windows 7 Pro, I could be on the rooftop, as you know I have been, on rooftops of buildings, pop open a laptop, strap it to my lap. I'm like, yeah, we're going. Windows 10, every time I do something, it's just a mess. It's annoying. And then I have to find out, as Suncast was good enough to remind me, oh, yeah, you can do those features if you have the enterprise version. So why should I pay more for an enterprise version since I don't maintain a domain on my laptop? What's the point?
Yeah. Oh, gee.
Yeah, that's why I'm telling you, I have a bias against cloud activities.
Okay. You're the kind of guy that likes to keep everything local on your computer. Yeah.
I like to keep things in my control. I'm getting a little annoyed at this third party. We take care of everything for you, but we really don't know what your business is about. But we just want your money, and thank you very much.
Okay. And I have by the way, we're going to bring our guest in just a second. I'm not holding him off on purpose because I bet he has an opinion on this as well. But I'll tell you what. Before I give my silly opinion, let's bring him in. Dana Puopolo is our guest. He is at Rowan University in southern New Jersey. Dana, you've been on the show before. Welcome back.
Thank you. My opinion is this. Here at Rowan, we still use Windows XP for everything. At the radio station. That's my answer right there.
Nice.
At the radio, doesn't the IT department, or maybe you are the IT department, but doesn't the IT department take a dim view of XP nowadays?
We're in our own little sandbox here. We have one static IP from the IT department. They've tried to accommodate, take things over. They wanted to virtualize the entire automation system here, and we told them that our experience with their streaming, because they host our shoutcast servers, of being down 5 to 7 hours a month was unacceptable. And so they kind of went away and left us alone. So we We are still running on Server 2003 here, the original version. We're still running on XP for the Audio Vault, and it just sits and runs just fine.
Yeah.
Now, I will tell you that my low power FM went off the other night. And when I got up at 5 o'clock in the morning and realized that there was no audio on the air, I went downstairs and discovered that Windows 7 had installed an update and rebooted itself. Thank you very much, Windows 7. It took us off the air. So it can happen. I mean, Microsoft, they work that way. They're designed for the average user. They're clearly not designed for the power user. I mean, and Macintosh really is. I mean, just it splits out pretty well in terms of what does what. Windows 10 to me, I'm running it here. I got suckered into upgrading. It runs okay. I prefer to be back on Windows 7, which is what I run everywhere at home. So I'm running Windows 10 on this machine, but that's about it.
Yeah. Well, hey, and this would be a good thing to continue to chat about. Of course, I used to do TV weather a lot. Did that for 15 years, and XP provided us with very few problems. But we've seen on Facebook and other places, the screenshots of a weather forecaster, doing the weather, and then up comes some notice from Microsoft that you got to do something. And some would argue, well, yeah, why would you use a consumer operating system for doing your TV weather? And I don't know. I'm sure people are in the know. So, you just do this and you do this, or you should use the enterprise version, or do this or do that. But you ought to be, at the Telos, at my employer Telos, we often talk about the tyranny of the default. And that is just such a killer. The choices that the developers make for the default behaviors, they're in very few cases are they going to be changed, especially by consumers. And so often, in a TV station environment, radio station environment, you may not have somebody who is an absolute positive IT professional inside and out setting up your system, or maybe you do have, and they're still not aware of all the pitfalls and pratfalls that could come along. With Microsoft doing their, I'll call it mischief, because it certainly interrupts with the flow of stuff. It's a tough situation. I use a Mac day in and day out, and I'm telling you, stuff just it doesn't do that kind of stuff. It updates stuff in the background once in a while. It'll let me know with a little notification. Hey, time to update this.
My daughter has a laptop, and it ran Windows 7 for a long time, quite well. She got suckered into upgrading it to Windows 10. It couldn't use the video driver for Windows 7, so it defaulted to 1024 by 768 graphics, which is terrible for a 17-inch laptop. And when we tried to go back to Windows 7 again, it would continuously blue screen, so it was unusable. They say you have so many days to default back. Well, we took her back to Windows 7, and found we couldn't use the laptop anymore. And what was very strange about it is that finally we left it on Windows 10, and she had these awful graphics and complained terribly until we discovered, for some reason, a Vista driver worked. Why a Windows 7 driver wouldn't work with Windows 10, but a Vista driver worked with Windows 10? Explain that one to me. So it's Microsoft. I mean, you have to live with it.
Chris, Tobin, what do you guys do?
Microsoft also owns Skype, by the it's
yes, they do. Yes, they do. And in some ways, I think Skype has gotten a little better. In some ways, it's gotten a little worse. It keeps changing. Chris, how about at your radio station? What do you do with this?
One thing that Microsoft owns Skype, and yet Skype runs better with Macintosh. Go figure.
Yeah, exactly. Chris, how about your station? What do you guys do with regard to the Windows XP 7, 10, all that stuff?
Right now, it's Windows 7 Professional. We do have XP on 2 machines that we're running our automation on for the studio. And as Dana pointed out, they are sandboxed, so it's not like as if we have to worry about anything there. And they've been running reliably. And funny thing, they're running that, was it the 2003 server? Yes, how about that? Who would have thought it still works? We're Windows 10 now. I have a laptop at the office that is running Windows 10, and as Dana pointed out, it's having a tough time running the various peripherals that worked just fine with the drivers from Windows 7, and now can't seem to find the LCD screen properly. There are times when the graphics just change. And there are times when, even though I've turned off the automatic updates, it still updates and reboots, or then tells me we've picked a new time to reboot your machine. It tells me it's found a new time to reboot it based on my, I'm like, really? It sits on the desk doing nothing. How did you come up with this metric? It's just, I get the concept of the default user, and most people don't know how to use computers, so let's make it as easy as possible. But you know what? I don't like the idea that the Windows OS, you as a common user, is automatically administrator, or in the other world, root. Whereas the other world, you're not root, you are a user. Right. Okay, so let's just remember these little details, and that's the reason why you get screwed, because since the basis by which everything functions is administrator access, you now got to work around that to try and make it even more default friendly. So I would say in places I've been at where we've had XP back in the day, we did find ways to shut down lots of stuff and lock down the box and try and find ways not to do things. I do miss the days of X Windows. At least then I could run a Linux box and have what looks like a graphic user interface in the front end that people are accustomed to. That worked really well. What a combination. But, they've got people upset. But, I don't know. It's just fascinating. I have been, in the last year, recommending more people to use the Mac platform. Go with Apple. Relearn a little bit of the intuitiveness of the product, and realize that you will, after probably the first month, notice that you haven't been doing those usual things like lifting your left leg while rebooting and watching things change, or maybe moving your hand and shaking your head and spinning around once and hoping that everything goes right. Or the $85 service call on the phone with Microsoft to find out why I can't log back in after I use the correct password, which is written down on my laptop because that's how secure we have to do things. Yeah. Think about it. Matt, Kirk, you pointed out yourself, you use a Mac all the time. And in the past, when you were on the other platform, how often did you run into an inconvenience? I'll call it. It's not a feature.
Yeah, I've got a Mac in front of me, but I also have a Windows machine here running my security cams here at the office and some ping programs. It's what I do. And this I kind of consider a second computer, and it is so annoying. It's still Windows 7. By the way, it's Windows 10. I still have Windows 7 in a virtual machine on my Mac. By the way, people say, what's the best laptop for Windows out there? And I tell them a Mac. A Mac will run Windows just fine, the virtual machine or the dual boot thing. But it's so annoying. Oh, my gosh. I wanted to point this out, and I'll bet you guys can back it up. So a couple of years ago, somebody came out with the results of a study as to what were the top things that an IT administrator could do to prevent their users from getting viruses and malware. And the top two things, and this cut out something like 98.7% of all malware infections. Two things: make people run as a user, not as administrator. Of course, the default, as you pointed out, is administrator. And secondly, don't use Internet Explorer. Use a different browser. Those two vectors, being administrator and using IE, if either or both were out of the picture, there would be so much less malware doing damage. Now, that was a couple of years ago. Malware's gotten smarter.
That Edge is better, which comes in Windows 10, of course.
Yeah.
There's a new browser.
Don't say Edge.
And actually, a lot of people don't know this, but Internet Explorer is still available in Windows 10. You can go into the program manager, and you'll find an Internet Explorer folder with Internet Explorer, because Edge seems to have a life of its own at times.
I have not tried it yet.
This is true. You don't have to. It automatically launches on its own.
I did just hear that one of the very popular ad blockers and is uBlock Origin. uBlock Origin. And it's terrific because you can easily turn it on and off. You come to a site that says, hey, we notice you're running an ad blocker. Would you please turn it off? Otherwise, we really can't deliver content to you. Easy to turn off, fairly unobtrusive. And now it is now available. I'm sorry, it will be available in a few days for the Edge browser. But it's been available for Chrome and Firefox and IE for a long, long time. I've got plenty of computers, just as most radio station engineers do, that aren't used by common everyday users, they're sitting in the background doing something, putting weather forecasts together or streaming, acting as some kind of server. And on those, I tend to not worry so much with updates and even antivirus stuff, which can get in the way. If a human's not using it besides me, I have a lot less worry about it. Yes, if there are shares, that could be a problem, but we sure got off on a tangent here. Our show is about FM antenna tuning, which thank goodness has nothing to do with Windows 7, 8, 9, 10, or XP. Also, Dana has for us some interesting advice on an El Cheapo STL system that he's been working with and having amazing luck with it, plus a tube-type headphone amp. All that's coming up. I got to tell you, our show, we're not going to break just yet for a sponsor, but our show's brought to you by the folks at Lavoo.com, LAWO.com/TWiRT. If you visit Lavoo, put the /TWiRT on there. It's important. And also by the folks at the Telos Alliance and their weekly e-newsletter called Direct Current. Spots coming up in just a few minutes. Chris Tobin is with us on this episode of TWiRT 329, and Dana Puopolo is with us as well. Dana, last time we talked to you, I want to say you were with a different station, and you're really happy here at Rowan University. It's in the southern part of New Jersey. Tell me a little bit about WGLS and your position there.
I've been working for Rowan University. It'll be 3 years, the beginning of March. They hired me to be chief engineer of their community FM station. It's actually integrated with the College of Communications. So there are 3 full-time employees that work at the station. The general manager, Derek Jones, the assistant manager, Lee Kirshner, and me. Now, Derek and Leo also teach classes. And ironically, both of them went to the university. Actually, it was Glassboro State College at the time, but they both have graduated from here. And I got hired 3 years ago. The engineer that was here retired after 30-something years. And it's actually a lot of fun here. It's a completely different situation from commercial radio, and that it's very low pressure. Dealing with the kids is great. Derek and Leo are sweethearts to work for. And it's just, you don't have the commercial pressure. The radio station is highly formatted during the day. It's an adult rock format, and they use everything that a commercial station uses. They have Marketron, they have RCS Selector, they have the Audio Vault, of course. Stuff is mostly analog here. It's a regional coverage FM. It's quite powerful. It's on a TV tower about 7 miles from here, and it's fun. The students are required to do an air shift during the day. There's a long training program, and they're tested at different points in time. And you'd be surprised. I mean, the logs that I get back, they keep operating logs, for example, and the logs come through perfectly. The students are trained to do things properly. And Derek and Leo stay on top of them. Many people, many students who have graduated from here have gotten jobs in radio, as a career. So it's a good place. It's enjoyable. It's WGLS is obviously, it stands for Glassboro, which is the city of license, where the college is. It's in Glassboro, New Jersey, which is about maybe 25 minutes southeast of Philadelphia. So Philadelphia is not far away. I still live in Pennsylvania. It is a New Jersey state school, and became a university in 1990 after Hank Rowan donated $100 million, which was at the time the largest donation to a public college in history, to what was then Glassboro State College, which is a teacher's college. So they are now Rowan University. They have a medical school. They have engineering college, College of Music, College of Communications, a business college. It's about 14,000 students, and people here seem to work very hard and play very hard. It's very serious, but it's different from commercial. It's actually quite refreshing.
So Dana, what prompted me to ask if you'd come back on our show is you wrote an article about FM antenna tuning and how absolutely critical that it is doesn't matter if you're a low power station or a translator, and I'm talking about an FM here, an FM antenna, usually side mounted on a tower. Could be 1 bay or 2 bay or 14 bays. I mean, there's all different sizes of FM antennas. And I've always felt that well, sure, okay, this is important to get the VSWR, that is the reflected power from the antenna, down as low as possible, getting back to the transmitter. And I've always felt that was important, but I think you want to tell us about it may be even more important than we thought. And so why don't you kind of give us a little basis about your discovery into the criticality of proper FM antenna tuning in situ on the tower itself?
Okay. First of all, I learned this from my experience working in television. Television, everybody sweeps their antennas. Because back in the analog days of TV, if the antenna wasn't flat from the carrier to plus 3.58 megahertz, which is where the color burst was, you could have a situation where if you're channel 5 and somebody tunes to you from channel 4, they had a nice flesh tone face on channel 4, and the faces on your channel are purple. So it's essential to have a flat antenna up through the color burst. Ironically, they pretty much let it go after that, which means by the time you get up to the sound carrier, which is 4 3/4 megs up, you can have some SWR problems. Now, the first thing that people have to realize is when they use the reflected power meter on their transmitter, that is, you correctly identified that as VSWR, that is voltage standing wave ratio, and that measurement can actually be meaningless. And I'll show you why with a simple graph here that I will draw. Okay.
By the way, while you're drawing that, I was going to point out that.
Go ahead.
I'm sorry. Go ahead. No,
this obviously is a sine wave. Okay. And a sine wave. This is one entire wave at FM, which the wavelength of FM at a 98 megahertz is about 10 feet. Now you'll notice. There's a point of voltage maximum, which is the crest of the sine wave, and a point of voltage minimum. And the problem is that this repeats itself every 10 feet. So if you happen to have your sensor, which is designed to sense voltage, at a low point on the waveform, then it's actually going to read lower than your actual SWR is. Because most of those sensors sense voltage, VSWR. So they have to be sitting right up here on the top of the sine wave here, at the very crest of the sine wave where the voltage is maximum to work correctly. And I've actually known people that have made the SWR meter read whatever they want just by changing the length of the transmission line a couple feet. But it doesn't, all it does is make the meter read happy. It doesn't affect, the performance of the antenna system. The antenna has to be swept under power, not voltage, and it has to be read with a power sensing device. Usually what people will use is they'll use a directional coupler, and they'll use a tracking generator and a spectrum analyzer to do this. The other thing about setting your antenna with the match with the SWR meter is you're actually only checking the antenna at your carrier. And it's important to know what the match is across the entire 200 kilohertz FM channel. Remember, with FM, if you're licensed to say 98.9, your channel actually goes plus or minus 100 kilohertz from that point. So you don't know, what this sweep looks like, at the lower and upper edges of the channel, just at the carrier. And that can change pretty dramatically. What can happen is with a lot of these narrowband antennas is that if the antenna is tuned incorrectly, you actually have a situation where the amplitude of the waveform will go up and down with modulation. In other words, if you've got a very narrowband antenna that when you're on the edge of the channel, it's got a lot of SWR, a lot of a bad match. You actually get amplitude modulation, which is put into the signal, which makes it harder for the receiver to decode the signal, requires a stronger signal, and also can cause multipath, generate multipath in the transmitter. So it's important to have the antenna tuned properly. What most people aim for is at the carrier, or actually a little above the carrier, you're looking for at least minus 25. And that minus 25 is what we call a normalized minus 25, because remember, when you send energy up an antenna, there's a transmission line loss involved. There's loss in the line to go up to the antenna, and then when the reflected power comes back, it also gets attenuated by the line as well. So you've got an up and a down loss. So you have to calculate that loss or measure that loss and take that out of your reading and add it to the reading. So if you've got, for example, 3 dB of loss, we'll say, one way, you then have to add 6 dB to the reading you get. So if you're at minus 28, the actual reading you would get would be minus 22, is what the actual antenna is reflecting back. Anything over minus 25 is considered very good performance. Anything under minus 20 is acceptable performance. And sometimes you have to take that, particularly in a multi-station antenna where it's a compromise anyway. But I've seen people put antennas on towers where the return loss was minus 10, minus 12, minus 13, and the antenna just doesn't perform. It doesn't perform well at all. You want to have every single watt that you put in get radiated by the antenna. You don't want it sent back. And the thing about it is, with tube transmitters, didn't seem to care about it at all. Solid state transmitters are more sensitive to it. And I'll give you an example. I installed a Nautel transmitter around 2001 at a major Los Angeles radio station. Let's leave it at that. I don't want to say the call letters of the station, but let's say that it's a well-known station there. And their morning man at the time was legendary. He not only did radio, but did television, as does their current morning man, who replaced this person. In fact, if you'll probably see him on TV come New Year's Eve, and that's as far as I'm going to go. So we had a situation where when we installed the transmitter, they had an RCA 10 kilowatt that they had run, a pair of them that they had run for over 20 years. And reflected power meter on both transmitters read 0, and they were number 1 or number 2 with the ratings there, and everything was great. They were on top of Mount Wilson, so they had a great signal. And we installed a Nautel transmitter, ran it for half a day in the dummy load. Their transmitter power output is supposed to be 8,800 watts. We ran the thing at 10 kilowatts for an entire day on the dummy load, ran beautifully. We switched the thing to the antenna, and it folded back to 600 watts.
Wow. Yeah. It was unhappy.
It was very unhappy. And we got in somebody from it was a Jampro penetrator antenna, C-Tech penetrator antenna. So we got them to come down from Sacramento with a return loss bridge, and we measured the response. It was a 2-bay antenna, full wave spaced, and the return loss, meaning the power being returned back down the line, was minus 13 dB.
Oh, wow.
Yeah, and of course, that's reflected power going back to the transmitter. Transmitter didn't like that, and it was folding itself back. Fortunately, they had a spare bay there, and what I was able to do was I was able to tune that bay properly. We didn't have a book on the antenna, but there was another station there that had the same antenna on 100.3, and they had a book, and I was able to actually do a ratio to determine the proper length. If there's 100.3 divided by 106.3, it's a fraction, you take it away. And so that's how we tuned each bay. When we were done, the new transmitter came up at 100% power. There was something like 8 or 9 watts of reflected. The return loss was minus 28 dB. But what was interesting is when we were driving down the mountain, Mount Wilson, there were places going down the mountain where there used to be multipath where there wasn't anymore. It was just gone.
Yeah. Yes.
And even more significant is the the board op for the talent, because they commented, we got the thing on the air about 15 minutes before the morning show started, and the two of them were talking, and they, the talent said, I didn't understand we were off the air, and the board op said, yeah, he goes, those engineers must have done something right, because I was driving in today, and there's places on the PCH where, the station is, you can't hear it. It's nothing but multipath, and today I drove right through, and it was crystal clear. So it does make a huge difference in the performance of of not only the antenna, but in terms of the performance of the entire radio station. It can also affect your base, because if you think about it, an FM signal is a bunch of sidebands. It's if you look at an FM signal, it's not just one carrier. It's a whole bunch of carriers.
Yeah.
And they go out theoretically to infinity from the center of the center spot of the frequency.
Mm-hmm.
Well, you determine the number of sidebands by what's called the modulation index. Okay, and what that is it's the deviation, which for FM in this country is 75 kilohertz, divided by the modulating frequency. Well, think about this. If you take 75 kilohertz and divide it by 15 kilohertz, you get a modulation index of 5, which means there's basically 5 carriers going above and below the frequency. Take that and divide that 75,000 by 50, or even 30, or even 20, which would be the lowest frequency of bass, and you get hundreds of sidebands that go out a wide distance from the carrier.
Yeah.
So if you've got an antenna that's narrow banded or mistuned, it's going to affect the bass performance more than the highs. And I've seen situations where we've retuned antennas and we've had to readjust the audio processing because now suddenly the station has all this bass it didn't have before. Because the antenna is letting the bass, radiate into the air.
Mm-hmm.
It's really quite simple. Before it was narrow banded, so of course you'd have to run more bass through. And of course, when you do that, you're now all of a sudden you can be louder because you're not having to equalize the bass to get more bass. You can back the bass down, and you get a flatter response, which is perceived as more loudness. You get the same amount of bass with much less bass going into the transmitter, then it changes everything. It makes the station sound apparently louder, and it is louder because you're putting out more mid-range and more high-end because you only got so much space to put audio in. So it's really important. It's really important. I mean, now also most manufacturers, when they tune an antenna, will tune the antenna so it's one channel high. The reason this is normally done is, especially in areas where there's icing, when an antenna gets some ice on it, it actually lowers the resonant frequency of the antenna slightly. So if you tune the antenna a channel high, what that means is when you get rain and ice on the antenna, it actually tends to reduce the SWR a little bit. And that tends to keep the radio station on the air better during icing conditions. It's not perfect. If you get too much ice, obviously, you go too far in the other direction. But most of the manufacturers usually tune it like one channel high or half a channel high. A properly tuned antenna, you will get a notch that will go down probably minus 50 or better at the bottom of the notch. And most of those, you can get at least a half a meg on either side of that notch and still be below minus 30. So most antennas will allow you to do this. Some antennas are more narrow banded than others. For example, the ring stub antennas, which are primarily used by colleges now, where you have the horizontal ring, which then does a 90-degree bend up and down. Those tend to be in a narrower bandwidth than the other designs of antennas.
Okay.
But you can still get a decent performance out of those. It's just that you have to tune the antenna. You have to be more diligent with the tuning that you do.
Dana, I got to pause here for just a minute, and we're going to hear from our sponsor. When we come back, and actually you just touched on something that I'd like to hear a little bit more about, and then we got a couple of the topics to hit. But I want to hear about the difference between some FM antennas. You actually can manipulate the elements themselves. They have sliding or turning screws available where you can actually tune the antenna bay. Other antennas, the bays are fixed for your frequency or near your frequency, and then there is a matching section either at the feed point of the antenna. And I want to understand, the different benefits of either way of doing that, because I've worked a bit with both. So hang on.
Sure.
Chris Tobin is with us as well, and Dana Puopolo is our guest on This Week in Radio Tech. I'm Kirk Harnack. We're learning about the importance of FM antenna fine-tuning and why it can really make a difference. Dana's got some real examples of that. Hey, our sponsor, Lavoo, L-A-W-O, I want to thank them. As a broadcast engineer and on-air personality and the host of this show, you know all that about me, but I've also sold broadcast equipment internationally. I've gotten to go into a lot of studios all around the world, in India and Singapore and Hong Kong and all over Europe, even in South Africa, in South America and Central America, even in Canada. and doing that, I've seen a lot of imaginative ways that people set up studios, the things that they do to make it convenient for the jocks, the talent, the board operators. And because I've seen all that kind of stuff, I'm excited to introduce you to our sponsor, Lavoo. That's LAWO.com. Now, Lavoo is famous around the world for television, audio, and video, especially for high-profile event coverage like the Olympics, World Cup soccer, Grammy Awards. So when the broadcast is mission critical, it's pretty likely to find a large Lavoo console there. You wouldn't believe how the stuff is built. It's over-engineered and lots of redundancy. The backups have backups, as they say. There are just no do-overs in live event broadcasting, and dead air can kill your career. Well, you may be thinking, well, why should I care? I'm not doing TV. This is a show about radio. Well, we know radio guys hate dead air even more. I mean, that's kind of all we got to sell. And that's why broadcasters like NPR, CBC, and the BBC, to name a few, buy Lavoo radio consoles. Now, being this involved in TV and radio around the world means that Lavoo thinks about the future a lot, too. Everybody knows that all types of media are converging on a common IP delivery platform, and Lavoo is ready for that. With broadcast gear that can handle audio, video, and control of every studio device using a single integrated commercial off-the-shelf computer network. And after that, well, Lavoo's got virtualization they're working on, about to bring that out, broadcasting from the cloud as well. So if absolute bulletproof reliability, 5 nines of uptime, and being future-proof are important to you, you owe it to yourself to find out more about Lavoo. Check out the website, www.lavoo.com/TWiRT. Please put the /TWiRT in there and give us a little credit for you visiting the Lavoo website, LAWO.com/TWiRT. Thanks to Lavoo for sponsoring This Week in Radio Tech. I'm Kirk Harnack. Chris Tobin's along from a comfortable home. And also Dana Puopolo's here from his office in southern New Jersey. Chris, I'm finding this pretty fascinating, and I'm glad Dana could join us. Chris, I know what your answer is going to be. I'll ask you anyway. Anything you're finding? A watt meter. By the way, is that a VSWR or does that one measure current?
This is here, and I thought my VSWR measurements were so accurate. Damn, I was wrong.
Yeah. Oh, you're right. Well, I thought
I got my directional coupler though. I got my directional. Oh, I can't do that either. Oh, damn, I'm so wrong.
I thought Bird advertised. Yeah, I thought Bird advertised that their watt meters measured current, but I don't know. I'm a little in the dark about that. I know the cheapie. The directional coupler that just comes with your transmitter or is built into the circuit board of the PA output of your exciter. Those indeed are really, just cheapy little circuits. They give you an idea, but as Dana said, they measure voltage standing wave ratio, not current there. Doesn't Bird measure current?
I think they're through. No, they don't, because the through lines are diode tap. The diodes, what do they call it? Capacitive sampling. I just worked on a TV transmitter
but a current reading meter will only be accurate at the current maximum.
Oh, that's true. Yeah, of course.
got to have a power meter in each direction. Yeah.
You need to do actual power. The power factors the voltage and the current in together.
Right. So you could use like an HP, an Agilent power meter on a tap, and then you could do the calculations from that, which actually is what I did this week with a TV transmitter. But Dana pointed out, it was interesting when he talked about the bandwidth, modulation index, and if you tune the antenna and the quality of the audio. I can tell you that way back in my early days of my career at an FM station, the music format was jazz. The engineering director was a genius, and we decided to go with a single bay. And everybody's like, oh, my God, single bay, that means no gain. That means you're going to have to do it all in the RF and the electric bill. So be it. But you know what? We got RF everywhere it needed to be for the audience. And what we did was we tuned the antenna so that it was pretty much center frequency and return loss. It's like, I think it was like minus 28 or something. That was pretty close to 1.05 or 1.0.
That's pretty well perfect.
Yeah, it was a rototiller. Okay, it was a rototiller ERI antenna. And we purposely did that. Then we had somebody tell us, well, if you do that, and as Dana pointed out, well, what happens when it gets cold and the ice is up? It's going to change frequency. So we came up with a plan, which is not uncommon. I mean, a lot of people, I think, used to do it. We put the heaters inside the antenna, to keep it from the de-icers. And instead of doing full voltage, we did, I'm not going to say it was a half voltage, but it was enough just to keep it warm. And what we did was we purposely had a way of adjusting the voltage for the current to see if we could make it work. And using a spectrum analyzer and Smith charts during one winter weekend, we watch it shift, and we're sitting there and going, oh, good, look, it's going to stay within. We could leave it at this voltage, and the temperature and everything was perfect. I know it sounds crazy, but when we did that, we went back, did the audio processing, looked at it, listened to the recordings, and as Dana pointed out, we didn't have to go crazy as we did on the low end or the highs or the mids, and we actually had to make a very bright sound. Fast forward several months after that little experiment, I get a phone call from a commission officer who says that he received a complaint that you're overmodulating for a jazz station. And we're like, what are you talking about? We're not overmodulating. We did a Bessel null. We're spot on. Come on up. Check it out. He goes, I don't have to. I've already done it. You're right. He goes, I'm just letting you know that I have to work, come up and see you and just do the motions. I said, all right, fine, whatever. Come on. FCC inspector I'm talking about. And it turns out I know the guy, so it's even better. So we come up, we're chatting, we're laughing, and he goes on his merry way. We're happy. Of course, the person who filed the complaint was our competitor in another format, classical format. And they were very annoyed at the fact that we just sounded way too loud. Well, to Dana's point, we tuned the system from studio to the top of the tower, so we maximized everything we could within the envelope we have to work with. And because the format was jazz, because the dynamics were large swings, high and low, whatever you want to call it, we had to do everything we could to keep it pristine, but also somewhat competitive. It worked. And to this day, I still tell people the same thing. And about a month ago, working with a friend of mine's engineering firm, we got hired to install a 2-bay antenna at a university in New Jersey, and we put up a 2-bay Shively, about 100 feet of cable, and we tuned it using, they have a tuning a splitter, what do you call it, power divider, and we tuned it with a spectrum analyzer, and that came in at 1.06. It was about minus 30 dB return loss.
Yep.
We didn't believe it. We thought there was something wrong, so I went up on the tower, moved stuff around, changed things, and sure enough, no, it's spot on. So we called Shively. And Bob Thread's already gone, but I forget the guy who we dealt with, Bob's replacement, and we told him what we found. He goes, oh yeah, you could do that with that antenna and that short length of cable. Oh, absolutely. But the best part was, if you read the VSWR or the VSWR meter, reflected meter on the transmitter, it didn't match. It was like telling us, no, you got it all. There's a problem with the system.
Absolutely.
It was great. So, we had to change calibrations and stuff and make sure everything stayed in check. But the Smith chart look, the spectrum analyzer, the sweep, I tell you, it was fantastic. And, if you understand the principles, as Dana points out, you can really maximize things. And the AM noise that Dana talks about, the old tube transmitters, you had that by default. I think it was just the physics of tubes. But I discovered early on, I'm sure Dana knows this too, the solid-state transmitters, the outputs are broadband. It's it's just a block of silicon. It says, okay, signal in and signal out at a certain gain, and oh wow, look at that signal. It's from 5 megahertz to 30. Well, we'll put it through anyway.
Yeah, not only that, but if you have something coming in that's being returned at minus minus 15 dB, it's going to be slightly amplified by the output of that solid-state transmitter, and it's going to be sent back out. And it's going to be sent back out with a delay of going up to the antenna, reflecting back down, and then going out again. Now that adds a transit time. So now you've got two carriers being sent out that are displaced in time. Okay? And if you've got if you've got a 1,000-foot tower, that's 2,000 feet of of displacement. You can divide that by 186,000 miles per second, and then figure in the velocity factor of the coax and do all that. And what you're going to find is that you can generate a significant multipath right there, just in the time delay. And that actually leads in well to Kirk's question about the different ways of tuning the antenna.
Yeah, for different designs. Yeah, different design of antennas.
Different designs. Most antennas, most small bay antennas are tuned by directly manipulating the bays. On a multi-bay antenna, what the manufacturer will do is they will actually build the antenna by what's called segments. They will say if you order, say you order an antenna, you're on 94.5. Well, they may make one model of antenna that goes from 88.1 to say 90.1, and then they make another model that goes from 90.1 to 92.1. What they do is they actually, when they manufacture the antenna, they don't manufacture it for your exact frequency. They manufacture it for a small segment of the band. Mm-hmm. Okay, and that's important because you can, if you're like in between with two segments match, you can actually sometimes, by going to the next highest segment, you can actually get a better performing antenna. What they do is in a multi-bay antenna, you remember you've got the bays usually, everything is in phase, which means that electrically the bays are exactly a wavelength apart. Okay, so two things happen. The first thing is because you're only dealing with the slight distance between bays of 10 to 12 feet, you don't get a lot of that self-generated multipath because the waveform doesn't go very far. It's not going all the way back down to the transmitter 1,200 feet away and then coming back out again. It's staying within the antenna, within the confines of the antenna. And I mean, and the longest the antenna is going to be is maybe 120 feet if it's a 14-bay antenna. So you don't have, a lot of this delay problem. Second of all, remember where the reflected power is going to land, there's an antenna to radiate it right there, and that minimizes it as well. What those kind of antennas that are segmented, they normally do, they will put a matching transformer at the bottom of the antenna. Now, there's two ways to do this. ERI does it with a slug on the transmission line, where you actually physically move a slug back and forth on the transmission line to tune things, and that works just fine. Shively uses a transformer, and so does CTEC and some of the others, where you actually, you pull on a knob, or you turn a knob, or you pull on a slug with a tool or T-bar or whatever. And that also, will work. And it's really interesting because I worked for a radio station in Rhode Island that was owned by a newspaper for many years, and they had a 6-bay, at the time, a dielectric antenna, which got hit by lightning, so they replaced the entire antenna. And the chief engineer installed the antenna, noticed the VSWR was fine, and went home. And 9 years later, I became the chief engineer, and the station never sounded right to me. It never really sounded good. And plus, they had a problem in that they were running two SCAs, and they could never get the SCA crosstalk down. In fact, the 92 kilohertz SCA, the coverage on it was severely limited. And what we found, when I actually had Shively come down to do that one, what we found is when we did this, we didn't use a return loss bridge. We actually used a network analyzer. We found that the plot looked like this. It was a circle. It was a huge circle like this. And I sent the rigger up the tower. The rigger was so interested that it actually started to rain. And he said, I'm going to climb anyway. I'm going to climb this 500-foot tower because I want to see what happens. And he got to the base of the antenna, and he said, okay, I'm at the first slug. And he pulled it out, and the circle went like this down to a dot. it literally went from this 4-inch diameter circle down to a little tiny dot, and we said, hold it, leave it, come down. Now, he had seen the circle when he came, and he had saw the dot when he came back, and he said, this does not look like the same antenna to me. Well, what we found is not only did it improve the sound of the station dramatically, but all of a sudden the 92 kilohertz SCA, instead of only going out about 6 miles, was going out 25 miles. And it actually made it more viable because they were using it to dispatch newspaper trucks, and they could not use it. And of course, they had Muzak on the 67, and the Muzak people were happy as a clam because all of a sudden these places that had signal problems, with broken antennas or whatever, they were constantly going out getting complaints that they could hear, static in the sound. All of a sudden that completely went away, and they had, good sounding Muzak in all the restaurants. And all it took was tuning the antenna. Just pulling on that thing. Now, think about it. That had been like that for 7 years. And we fixed it in an hour and a half. It's money well spent. And, the antenna companies will do this service. Most of them will do the service for you, or you can have a local consultant. And it's interesting, the people know how to do this because TV people do this all the time. It's routine with installing the antenna. You tune the antenna, you sweep the antenna, you tune the antenna when you install it. But for some reason I can't fathom, most FM engineers just don't bother. So there you are.
I think it's just a lack of knowledge. I think it's a lack of knowledge and understanding the impact. Because I can tell you that early on in my career, I had a chance to work with the folks, and this is probably going to date me again, but what the heck, a technology called FMX, okay, which is basically an expander compander on the L-R. I'll put it in the simplest terms. The best part of that project was I worked alongside some guy named, what was his name again? Oh yeah, Emil Turek. I know the name, but you may know his work, the CBS Volumax, Automax, the papers he wrote about the human ear and the hearing, and the CBS loudness meter, which is still used to this day.
Absolutely.
Or the algorithms the ballistics, the weighting that's used, and we did. What was the guy's name? Dana, maybe you might remember, and he was an RCA transmitter engineering consultant, Dean Sargent. Yes. Those of us who've been around long enough probably remember him. He was a salty guy, but he came out with the folks from the FMX Associates, Brown Associates, Fox Brown Associates, and he comes out. He sits down. I may have told this story before. I'm pretty sure I have. Comes out to our transmitter site, and it's a 500-foot tower with a rototiller on the top. Continental FM transmitter operating in 10 kilowatts, and he comes out. He looks up. He goes, "All right, here." He pulls out a napkin from his pocket. Pencils on the napkin. Here are the numbers we're going to see on your transmitter for group delay. We're going to do the following. Here's what I think the bandwidth or the tuning will be on your transmitter. You're at what? 96.7? Okay. Yeah, figure these numbers and goes, okay, hold this, put it in your pocket, don't let me see it, and let's go inside and do our thing. So we grab network analyzer, the 80-pound HPs, pull it out, go inside, and there he is pulsing this 10-kilowatt FM transmitter that we're operating at 8.25 kilowatts, and we're watching the carrier go up, go down, up and down. I'm like, wow, can you really do that? Pulsing? Goes, oh yeah, it's fine. We're just measuring group delay. Like, okay, fine, I'm hoping I'm on the air tomorrow morning.
With FMX,
go ahead, Dana.
The L-R was in the companded L-R was in phase quadrature with the main one, which means that the timing delay and the phasing delay was critical for that. I mean, it would not work if your antenna was out of tune. I think that was part of the reason why FMX didn't actually take off, because there were just so many mistuned transmitters and antennas that the system wouldn't work. Everything had to be perfect for it to work. But when it worked, it was amazing how well it did.
Yeah, well, so that the experience I took away from that, or the understanding, was exactly what you point out, Dana, was that there are many elements that required proper measurement and tuning in order for it to work. So here we are doing this group delay measurement and the whole bit for the system, and then he goes, "Okay, here are my numbers." Writes them down. Goes, "Hand me the napkin." Okay, now look at them. I'm not going to look at anything. And he turns his notebook around toward me and all the others, and we look at it. And let me tell you something. he was off by maybe a dB on a few of the measurements. Here's a guy who walks up, he goes, "Oh, it's a ERI? I know exactly how they make their antennas, what they do, no problem." Length of cable, you got cable wave, inch and 5/8. Yep, okay, I know exactly the velocity. And Continental, oh, please, all right, I know what that guy's going to do. That's how good this guy was. But the thing was, what I learned from that, was, as Dana points out, FMX, when properly set up, it worked like a champ. And now I'm talking this is a jazz format. So we're talking a Class A jazz format running FMX. And I was driving around in the van. We're doing the measurements, both 5 to 10 feet above the van dipole, as well as just a basic car radio, because that's the reality, is the car radio height. And boy, we're like, wow, this really does extend it a bit. It makes a difference. But what I was dismayed was that the fact that the entire people behind FMX, I'll say that, did not explain to the engineering community or to the broadcasters in general at the papers, at presentations, that you need to do these parameters. You need to make these measurements in order for it to function properly, because here are the physics behind FMX. Fast forward to HD radio, and HD radio folks, Ubiquity and others, tell you got to make sure, in the case of AM, make sure your antenna system is linear, flat. Otherwise, HD AM is not going to work. Now, I worked at an AM site. We had a 4-tower array, and before we implemented the HD, we brought in Tom Jones, Carl T. Jones, and we spent several nights tuning, tweaking, adjusting the 4-tower array out the Meadowlands, which is not an easy thing to do, because if anyone who's familiar with the Meadowlands knows that not only does my transmitter doghouse or tuning house have to pass my signal, I have to reject the other signals across the way, which are operating at equal power.
There's a million of them, yeah.
Exactly. So you're tuning for your best performance on your tower, and then all of a sudden you have to look at the other reject filter and go, yeah, okay, that's not working too well anymore. I got to turn that. Oh, we just lost the linearity on this. But is it time consuming? Absolutely. Is it worth it? Beyond your belief, because to this day, that small little AM 50,000 watt radio station has the most flat, cleanest sounding, best performing HD you could ever imagine, all because we made sure it was a linear.
And just as Dana, I would also say this. Why do you think it is that the single sideband FM stereo that people are touting might have less multipath? Could it be because the bandwidth of it is narrower, and therefore the antenna tuning isn't as critical?
Yeah, there's energy out there that bounces around first because it's higher in frequency has more group delay. Hey guys, we got to take a quick break here. I was too optimistic about all the topics we could get to. We've covered FM antennas really nicely, and I appreciate that. But we're going to come back with a tip from Dana Puopolo, and man, I tell you what, if you want to build something inexpensively that works, follow him and get his advice. We're going to have to put off the El Cheapo STL to another episode later on.
Sure.
And maybe Dana can show us his really cool headphone amp. But that's coming up in just a minute. Our show is brought to you in part by the folks at the Telos Alliance and the Direct Current e-newsletter. And this week's Direct Current features something really cool. Chuck Lakatos, the former director of engineering at Alaska Public Broadcasting, he talks about living in Alaska, engineering in Alaska, what an adventure it is. And so here's a little message from the folks at the Telos Alliance about direct current.
Not much in the paper today, is there?
Yeah, not much. Seems tough to stay informed,
Like we're missing out on stuff, important stuff.
Yeah, feels like week-old news, yesterday's stories. Half the tech stuff in here seems out of date by the time I see it.
What Kirk doesn't know is I'm way ahead of everyone else around here. Every Thursday, I get this newsletter in my email. It's Direct Current. The folks at the Telos Alliance publish this.
What Joe doesn't know is I keep one step ahead of the radio guys in this market. Every Thursday, I get Direct Current from the folks at the Telos Alliance. It's a free newsletter about radio engineering, audio, streaming, studios, everything.
Thursday afternoons, we have our department head meeting. I look like a genius, thanks to the knowledge, updates, and advice in Direct Current. Sometimes I wonder if I should tell Kirk about Direct Current. Might help him out.
I wonder if I should let Joe in on my secret. he could use a little help sometimes.
Nah. Get Direct Current in your inbox every Thursday. Read profiles of engineers and newsmakers in the broadcast community. Get technical pointers putting you and your facility at an advantage. Important industry news and views. Plus, you'll be up to date on Telos, Omnia, Axia, and Zipstream products. It's all here in the Direct Current newsletter. Subscribe online at telosalliance.com/directcurrent. That's telosalliance.com/directcurrent.
And besides the article about Chuck Lakatos in Alaska, there's also a great tech tip about using a service called Digiphone. Maybe you have an IP codec, but you need to talk to a client or a production house that has an ISDN codec, and you're not shucking and jiving. Well, Digiphone is that bridge. It's very cool. There's an article about that, tech tip about that, in today's, actually, Direct Current. So check it out from the Telos Alliance. Go to telosalliance.com/directcurrent. All right, Chris Tobin, maybe you have a tech tip for us this week.
Absolutely. Why wouldn't I? And Digiphone, is that the Dave Immer service?
Yeah, it is.
Digiphone?
Dave's a great guy.
Connecticut?
Yeah.
Yep. Yeah. Okay, good. Yep. Just want to make sure. He's definitely a good guy and definitely provides a service that people should take advantage of if you don't have the wherewithal to do it right. Well, the tech tip, it's that time of year. No, it's not. It's a time of year all year long. I recently did a preventive maintenance visit, a monthly visit for a TV station for a friend of mine who's taken ill. And what we do is the usual measurements for the transmitter parameters, the whole bit. But we also check the air conditioning system, make sure it's running, the UPS. And the one thing that people always overlook, and I've worked at many places where this has happened, and I've gotten calls to come in and help on an overnight for burned bullets. Make sure you do the measurements with an IR thermometer, okay? And the reason we do this is because you check your transmission. Let's see what you get here. Look at that, 75 degrees on my head. How about that? Hot-headed that I am. And you can catch. Now, you record this. Now, do a regular recording. Log it, whether it's weekly, monthly, whatever you do. And you can catch, possibly, a failing transmission line component because of the temperature change. Because you may not feel, you're not going to be able to touch it and say, oh, yeah, it's hot or cold. If you can feel the temperature increase on a transmission line with your hand, you're now past the point of no return. Because remember, we don't have that much sensitivity on our fingertips that we can feel it before it becomes troublesome. I'm serious. I have, we're talking, this is a, 15,000 watt UHF TV transmitter system. So you're talking 3-inch lines, and there's no way you're going to feel a hot spot with your hand. And I've seen when I've worked at the Empire State Building many years ago, back in the late 90s, a couple of FMs had a bullet burn in their transmission line up in the area, what they call the E levels, back in the old days, the Alpha antenna system. The E levels of the Empire State Building are where the colored lights are, when you see the red, white, and blue, or the blue, orange, and green. And that blew out. When that blew out, the entire combiner system came apart because one of the bullets burned. So this is something worthwhile. I think the latest price on this guy is $70 or $80. It's worth it. And you can check other stuff too. I mean, you can power supplies, your exciter. There's all kinds of stuff you can do. Computers,
Don't
whatever.
Forget to do it on the fuse box too.
I was just getting to that.
Do it on the fuse
hot
box.
spot on the fuse box. Exactly. That's another thing. Yeah, thermal imaging on your fuse box is something you shouldn't overlook. So that's my tip. Go for the fluke, like I always say, the 62 Mini, the fluke.
And I was thinking, you said you couldn't notice with your fingertips if a bullet was having a problem inside. There's, depending on what kind of transmission line it is, there's anywhere from 3/4 of an inch to 3.5 inches of air between you and that bullet. So and plus the piece of metal that you're touching. So you're going to look for a subtle difference there, because subtle on the outside is going to be big on the inside. So
right, think about it. You got a 1/2 inch of airspace, and you're able to feel a problem. You're beyond the point of no return. I mean, you're at a flashpoint.
Yeah.
Absolutely.
All right, Dana, we just got a couple minutes. What is your quick tip for our listeners?
My quick tip is a place where you can get some really good equipment really cheap. It is Gearbest.com. Gearbest.com is a website in China that sells all kinds of neat stuff. For example, you can buy an AKG 240 cloned pair of headphones there that look like them and actually sound better than them. and you can find them for as cheap as $19 there, including shipping.
Wow. Yeah.
They have all sorts of neat stuff. They have phones. I even bought my FM antenna there. I paid $139 for my 1-bay FM antenna. And what was interesting was it came, and it came in a plastic package that looked like it was hanging on the wall somewhere. And sure enough, I mean, and the brand was FM User. And sure enough, when I went into the FCC database for FM antennas, the FM User CP100 was listed as an accepted circularly polarized FM antenna.
Oh, my goodness.
So if you look on the license of WZML, that is what you will find as the antenna. $139 from China. And like I said, it came in a clear plastic package that had a peg to hang on the wall.
Oh, goodness. Wow.
That's my tip.
Well, that's and I have bought things from Gearbest, and usually computer memory cards that may or may not be their rated value, but they sell the there's all kinds of electronics. It's amazing what they sell there. Now, my experience, Dana, and you may have found the same. You order it and you think, wow, this is really cheap, and the shipping is pretty low even from China, and then a few days go by. And a couple of weeks go by, and then a month goes by, and you've forgotten all about that you ordered it. And then one day in the mail, it shows up. You think, oh, right. Yeah, order this. Exactly, it's like Christmas.
Yes, that's been my experience as well.
Here's something I ordered.
At the point where I think, wait a minute, didn't I buy something from them a month or so ago?
Exactly.
And then the next day it arrives, so I feel better.
I love buying. I've got a couple of expensive watches, but I love cheap watches too. But I always I have smaller wrists that they always say they send the full. I got to take the links out, and so I bought this little thing to push that peg out from a metal wristband. And oh my goodness, this was $1, and you can even adjust the height of the table right here so that you can get that wristband in just the right place. You get the peg here. The pin to push the pin out of the wristband, and there you go. You can adjust the table up or down there, and it's inexpensive and it's cheap too. But
by the way, this is my
I agree.
Terabyte hard drive.
This
is my right here.
I've got a terabyte here too. I think this one actually is a terabyte. It's the 2 terabyte ones that may not.
This
exactly
is a 3, and only it's not a 3.
Yeah, exactly. I hear you. Hey. We got to go. Dana, it's been a pleasure and a lot of fun. We talked about FM antenna tuning, and we'll have you back to talk about your El Cheapo STL, that idea that would be very valuable for a lot of folks, even as a main or as a backup, which we all need backups. So, Chris Tobin, thank you so much for being here. I appreciate you and your brother providing you a studio today.
Yes, thank you. Yeah, it was good. I had a good time. And, learn the technologies, as I always tell people. Just as Dana pointed out, why don't people understand the differences? And, 7 years of a poorly tuned antenna and the performance, that's lost money.
Yeah. A lot of money, a lot of poor performance, as the big station in Los Angeles found that as well. Hey, I went to a station one time, and VSWR had always been high. I got to investigate. There was no place to tune it. It was an ERI, and I've told the story before. I pulled the center conductor out of the matching section, compared it to the sheet. It was upside down. It had been that way.
Yes. One final story before we leave that you were like. I was director of engineering of a small chain of TV stations, 3 TV stations. And one night I got a call at 3 o'clock in the morning from our engineer in Texas, in a major city in Texas, who informed me that the TV station was off the air. And I was half asleep, and I asked him, well, what are the meters reading on the transmitter? And he said to me, I'm going to have to find a flashlight to do that for you. And I asked him, why will you need a flashlight? And he said, because all the lights in the building are off due to the power failure. And I'll leave it at that for today.
That's hilarious. All right. Thanks so much, Chris Tobin and Dana Puopolo, and also to Suncast for producing this episode of This Week in Radio Tech. Also, thanks to Andrew Zarian, the founder of the GFQ Network, where you'll find many other fine podcasts, including What the Tech. Oh, And since you are hearing or watching this podcast, you should be aware that there is a little sweepstakes going on. I know we put this on Facebook. It's not for the general public. It's just for listeners and viewers of this podcast. Go to your Facebook page. Go to This Week in Radio Tech's Facebook page, and you'll see a post there and a link. We're giving away a couple of the Amazon Fire 7-inch tablets, and we're giving away not one but two, and they'll be given away next week. They'll be chosen at random by the randomizing people at Amazon. And I won't know who they are until they win. So we'll probably, I guess we'll announce it on next week's show. We should know by then. I think they're going to be given away on Wednesday of next week. That will be the, what is that, the 22nd or so? Or is that, I should know. Let's see. It is the 21st. They'll be given away on the 21st. We'll announce it on the 22nd. So go register with the link on our Facebook page for This Week in Radio Tech. All right, we got to go. Take care, everybody. We'll see you next week on This Week in Radio Tech. Bye-bye.